So you don't have to be dead silent, but you do have to be kind of silent. So we're gonna test this because we have some students out, and maybe someday you're gonna be out. And Colin wishes I did this the other day, right? So here we go. Lesson 3. Read what's in the box and tell me what you think today is gonna be different. Because we've been talking about how it always seems the same. We just have to think harder every day. What's different about today's work? Marshall, what's different about today's work? This is not a trick question. Read. Yes. Today we're going to compare. So we've been finding a lot of rates of change and finding a lot of initial values and finding the total, dependent variable, whatever. Today, we're going to compare them, which means we have to find them first, right? So we have to go back to the old stuff that we know and then compare. A zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of the zebra. Compare their speed. So we have to find the rate of change for each. Oh, well, the lion's easy. What's the lion? 53, yeah. That one's easy. So this one's rate of change is 53 feet per second. A lot of times when we write things in math and science, we use that slash means per, okay? Now we need to find the rate of change for the zebra, which is given in a graph. So Davin, what am I going to write when I'm looking for rate of change given a graph?
The rise and run.
Rise over run.
Done.
Okay. So I need to find what? Where am I going to start? What? A pretty point. Right. Oh, look, 0, 0 is pretty. So I'm going to go up. Here's a pretty point. Here's a pretty point. Okay. So I'm going to go up 1, 2, right? Oh, Lainey, how many is that?
60.
That's really 60. 30, 60 over 1. So a zebra runs 60 over 1. 60 what?
Feet.
Over 1
Second.
Oh, so it's 60 feet per second. Now, we can't just stop there because when you are asked to compare, that means you're going to write a sentence describing, and you're going to use the words greater than, less than, or equal to in your answer. So I'm going to write, says, compare their speeds. The lion's speed is less than the tiger's. Zebra speed. Lions and tigers and zebras, oh my.
What is that?
I don't know.
You don't know what a zebra is?
Okay.
No.
So, you could also say the zebra speed is greater than the lion's speed. So in math, your sentences don't have to be that like fluffy like in English, right? The lovely lion's speed is 500 times light speed. I don't know. But in math, it's just blah, blah, blah. Okay? You with me? All right, try this one. Ooh, looks like we're going to have to find it using two. Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill is represented in the table below. Benjamin's monthly cost is shown in the graph. Determine who has the greater rate of change. Now I have to do work for both of these.
Oh, come on.
I have to label that this work is Angela. And to find the rate of change for a table, what will I write? Josie. Change in Y over change in X. Okay. What is my change in Y, Colin?
Yes.
Yes. Let's try again. Ready? How many from 30 to 35?
Oh, wait, no, that's 5. And then,
And how many?
yeah.
How many from 35 to 40?
Yep, that is 5.
And how many from 40 to 45?
5.
So the change in Y is 5 every time you go up or down row. Okay. And what is my change in X, Henry?
Your change in X is 50.
50. So what is the rate of change? Kate,
1 over
1 over 10. 1/10, right? Can you tell me what that means, Kate?
Well, it would mean that for every 10 minutes, $1.
Oh, yes, you got it. So this is your X and this is your Y. Change in Y, that's $1 for 10 minutes. Okay? All right, let's do Benjamin now. I'm just going to write Benji.
Wait, isn't that a movie?
Probably.
I'm pretty sure I've seen that movie.
Nora, what formula will I write to find the rate of change from a graph? You guys are getting so good at this. I've only had to beat it into you and yell at you a lot, but it's working. All right, so, oh goody, here's a pretty point. Where's my next one? Here and here. All right, so every time I go up a square, Violet, how much is it worth? Think again. 5, good. So 5, 10, 15 over what? 15, Lexi, over what? 50, good. So this one's 15 over 50. What's that rate of change? 3 over 10. 3 times. Am I done?
No.
No. It says determine who has the greater rate of change. So I have to write a sentence that says Benjamin has the greater rate of change. There's a little note at the bottom. In order to compare the rates of change, either you have to graph both functions and compare their steepness, or you have to calculate M for both functions. Okay? Cool. Let's try another one. The graphs below show the relationship between elapsed time and distance traveled by airplane A and airplane B after each airplane reaches its cruising speed. This sounds like it's going to be terrible, right? Yes. The airplane leaves the airport at 5:45 while airplane B, no. So, oh boy, airplane C, guess what? Airplane C is traveling at a different speed, and the equation of that one is y equals 27/6x can be used to determine y. The number of miles traveled by airplane C in x minutes. So I'm just going to put right here x is minutes, which is the same for those, so that's good. Which statement accurately compares the cruising speed of plane C to airplane A and B? This sounds terrible.
I don't think we have enough space on the.
So it does, because what? All we're doing is we're comparing the speed of all three. So let's find the rate of change for airplane A. Slope equals. What's the rate of change for airplane A? Pretty points. Oh my gosh, are there any pretty points here?
Yeah. Top one of top one.
This one? That's awful.
No,
Alright,
that's not correct.
why?
On the paper, it's not. Here, come on.
I'm gonna need.
It's off.
It's an unpretty point.
Yeah, well, we're gonna call it a pretty point because I don't know what else to do. So 30 over 6, which is what? 5. Okay. B. Slope is, let's find, ooh, this is much.
They're all pretty good.
Okay. Slope is what? 4. And C, just looking at the equation, you know what the slope is. What is it?
4 and 3.
Oh, it's 27 over 6, but Ryan's like, oh, 6 times 4 is 24, so that leaves 3 left over, so that one's 4.5. All right, so now that we know those, we can look at our choices better. The cruising speed of airplane C is less than both airplane A and B. Is that true? No. The cruising, should say speed, of airplane C is greater than both A and B. Is that true? No. See, when you do this prep work, it's good. The cruising speed of airplane C is greater than the cruising speed of airplane A. No, I'm not even going to read the rest. Let's check D. The cruising speed of airplane C is less than airplane A and greater than airplane B. Is that right? But in order to do that problem, you needed to know how to find slope from a graph and where slope in an equation. Now, that was a multiple choice question. Kids usually think those take like 1 minute. Not so much.
Like 2 minutes. Oh, flashbacks.
Okay, do this one.
Are we doing? Oh, yeah. Wait.
I need my calculadora.
That sounds like something you would say in Hawaii. Calculadora. Like, yeah.
I don't know where that comes with anything. That comes to me.
You think of every possible way.
Hey, this is genuine question. Hey.
Oh my god.
Isn't any answer correct?
Hang on.
Oh, no, it's not.
Same.
It's not. Yeah, the answer.
Which statement accurately compares the speed of the train? It's right, but ooh,
I knew it.
that's a stinky stink, isn't it?
What?
Those questions make kids like you guys cry during tests. You're like, I don't understand. I've done it 15 times and they're close. So you have to go back and read the question carefully. Hey, good. 3.6 homework.
Oh,
Yay!
Oh my god.
do I have to hit my head?
Fun.
Do I have to hit my head
You
or
have to,
find
like,
it again? Not
Yeah, no, right,
There's
right now.
100% the total.
Do it. You have to do, I want you to do it right now.
Oh, there's only 3 questions.
Tonight, you're gonna do, there's 2 questions on this page. I know it's ridiculous, but there's 5 questions.
Wait, hold on.
I like space, so I spread them out a lot.
Why can't
When
we?
if all are on the same page, like when everything's written so little, I can't read it.
Me neither. Yo, dang.
Oh wait, I have to stop the recording because I don't want it to go on
Miss
forever.
O'Malley, if I drew on the smartboard, would that be the recording? Like if you brought up one of those like
I think
blank
so.
screens,